Arnav sir, you can share your screen, please.
Screen is already shared, I think. Is the screen visible?
You can reshare that once it's not
Please.
visible.
It is it
Yeah,
visible now?
yes, sir, it is visible. So, good afternoon, everyone, on this wonderful day for an international conference. I invite Dr. Arunava Majumdar, Assistant Professor of Mathematics Department from Lovely Professional University, Punjab. So he is going to deliver numerical methods and computation techniques for solving engineering problems. So, like every engineers in during their degree, they are learning some numerical formulas, numerical analysis they are doing. So how they are going to implement on a day-to-day engineering problems. So that's what Dr. Arunava is going to explain today. So without wasting much time, I once again welcome Dr. Arunava Majumdar sir. Sir, you can continue with the session.
Okay, thank you, thank you. Actually, this is I'm very honored and I thank to the TEMS Tech Solutions for giving me the opportunity for this lecture. And today I am going to discuss about the numerical methods of and computational techniques. There are many problems, engineering problems. Actually, basically all engineering problems it turns into some mathematical equations, and that equations may be the simple mathematical equations, or maybe the ODE, that is ordinary differential equations or partial differential equations, or integrations, that is many times you need to integrate something, some difficult equations, or you need to differentiate, or there are some system of equations, maybe linear, maybe nonlinear equations are there, and solution of that kind of techniques mathematically it was very difficult. Okay, so that is why the numerical techniques or numerical and computational methods that comes into the play. This method, numerical methods, is actually any kind of mathematical problems. It may be any system of linear equations or any kind of mathematical equations that can be solved by using numerical techniques. So some of the techniques, selected techniques, which are very much important for modern day computations, I would like to discuss today. And let's start with my profile. What is my research interests? I generally my research area is optimization techniques and the numerical optimizations, supply chain management, multi-criteria decision making, which is another decision making techniques, sustainable development, and disaster management. These are the main focus area of my research, and generally I research on the optimizations and the techniques, are different types of techniques and optimizations, how to find the global optimum solutions or local optimums using different numerical techniques. And this is my profile in Google Scholar, and my total citation is 385. Almost I have total number of publications as more than 20 publications, and my H index is 9. And you can follow me in LinkedIn, in Facebook, Instagram, and YouTube also. So now I'm going to start with the numerical solutions of system of linear equations. Generally, in every engineering mathematics, the in first year, students starts with the starts with the linear algebra, and linear algebra definitely it is actually defined with the mainly matrix equations, matrix determinants. So matrix is nothing but the system of linear equations. So non-linear equations is also there, but today I'm talking about only linear equations. So now here we can see. So this is the General form is the general form of the system of linear equations. So many linear equations are there. This is equation number 1, equation number 2, and this is, you can see, m number of equation number m number of linear equations are there. And how to solve it? When we are going to solve it, this is by using numerical techniques. How can we solve this system of equations? This is what I'm going to teach you. So, and one example of this one is, look at this, is equation number 1, equation number 2, and equation number 3. So three equations are there, and first equation, there are three variables, and three equations are there. So always remember that if the number of variables are less, okay, and the number of variables are less and number of equations are more, then that equations, it cannot be solvable. Okay, that systems are called inconsistent. So basically, when the number of variables are three, x, y, and z, you must have three equations to solve that systems, and you can get an unique solutions. Okay, so there are three cases are there. First case is equations, that is number of equation and variables are same. This is case number 1. Case number 2, number of equation is more and variables are less. This is case number 2. And case number 3, number of equation is less and variables are more. Okay, so remember, for to get any unique solutions, we need the same number of equation and variables. Okay, when the number of equation in more is more, that is case number 3. Okay, number of equation is less and number of variables are more, then we get infinite number of solutions. That is in this case. Okay, many solutions. And equation 2, number of equation is more and number of variables are less. This is called inconsistent system, and we can get no solution. So these three cases may appear. Now, numerical techniques. Now I'm not going for the, I told you that we will study only numerical techniques to solve these kinds of systems. So there are generally two methods, that is very popular methods are there. One is Gauss elimination method, and another one is sorry, first one is Gauss elimination and second one is Gauss Seidel method. Okay, so here we will talk about a solution process based on the Gauss elimination method. Gauss elimination. And first I have to just transform the equation. Suppose a linear system of equations, like suppose 2x plus 3y minus z is equal to 1, 3x minus y plus z is equal to 2, and 5x plus 2y minus 2z is equal to 3. So these three equations can be, okay, uh, used as a matrix formation. It is 2, 3, minus 1, 3, minus 1, 1, 5, 2, minus 2. Okay, and this one, 1, 2, and 3, this is right hand side, it can be written as 1, 2, 3. So this is the entire matrix formation, and which is called the augmented matrix. Okay, and now we apply elementary row operation, elementary row operation on it. Now what is elementary row operation? There are column operations, there are row operations, many operations are there. Okay, to transform this matrix to an equivalent matrix. Now what we need to do actually in Gauss elimination method, we need to, that is, you can see this lower part, this triangle. Okay, you need to have this part element, this element, and this element. You need to convert them to zero. Okay, you need to convert them to zero. That is, if I have the equation like this, suppose a b c d, 0 e f g, 0 0 h I, like this. That is, after elementary row operations, we need to convert this system of linear equations or this matrix with this particular form. Okay, and how to do this? This is very big method, and I'm not going to discuss it right now because of the less amount of time. Okay, so actually what we are in numerical method, what we do actually, we are doing this technique, and after doing this technique, this is very easy. That is, after doing it, you can see we can get three equations now. The first equation, it is ax plus by plus cz is equal to d, and the second equation, since it is 0, so it is 0 into x, and it is ey plus fz is equal to g, and the third equation, it is 0 and 0, so obviously we are get h into z is equal to I. So look at this, from equation number 3 you can easily find out the value of z, z equal to I by h. And if I put this value of z here, we can get the value of y, and after putting value of y and z in equation number 1, we can get the value of x. So this is the process. Now what we will learn today, that is, this kinds of these techniques are very computational. That is, by hand calculation is very time consuming. So that is why today I will give you the how to solve it by using the software MATLAB. That is what kind of technique, that is what kind of that is command you need to use. Just you write down the equations in MATLAB, and MATLAB can automatically solve it for you. Okay, so you can see here, so this is a MATLAB code, and you can see there are three equations, and equations are written in MATLAB like this. This is equation number 1, equation number 2, and equation number 3. So actually the equations are this: 2x plus y plus z is equal to 2. This is equation number 1. Second equation is minus x plus y minus z is equal to 3. Third equation is x plus 2y plus 3z is equal to minus 10. So these three equations are there. Now you need to put these equations into the MATLAB just simply by using these three command. Okay, these are actually not command. Sims, it is the symbolic notation in MATLAB. That is, sims means there are three variables we use, x, y, and z. So that is why the symbols x, y, and z, it is used in MATLAB. So sims is just to define the symbols. So equation one is a variable. Just you need to write these three equations like this. Okay, after that, ab, equations to matrix. That is, just in the previous slide you can see these system of linear equations. The system of linear equations can be transformed into matrix like this. So exactly in the same way, if in MATLAB we use this command equations to matrix, within bracket equation 1, equation 2, equation 3, and xyz. Okay, and easily this can be it will convert these three equations to the matrix form. And after that, what is the command we need to use to solve these equations? Lin solve. This is the command in MATLAB. So here you can see, by using the MATLAB software, you can easily see any kind of easily solve any kind of system of linear equations. So now I will uh, use this one. That is, I am going to give you the demo in MATLAB. Okay, so hopefully it is visible to you. So this is the MATLAB equation. You can see I have used this MATLAB command CLC seems XYZ. This is equation 1, equation 2, and equation 3. Okay, A, B. So this is the equations to matrix notation, equations to matrix. Okay, within third bracket, equation 1, equation 2, equation 3, and XYZ. That is these three equations, and these are the three variables. After that, if I display this one, now I am running this, you can see. So if I display this, so this is the matrix. Okay, this is the matrix. You can see 2 1 1. This 2 1, there is y coefficient is 1 and z coefficient is 1. Right hand side is 2, so right hand side is 2. And next equation, minus 1 plus 1 minus z, so minus 1 plus 1 minus 1. And right hand side is 3, it is 3. So the entire matrix is here. After that, I have displayed this matrix. So after putting this display, these are the display in matrix. And then I use this particular command, linsolve AB. So linsolve AB, it will solve these equations, that is x equal to linsolve AB. Since there are three variables x, y, z, so obviously we need to have three values. So this is the value of x, this is the value of y, this is the value of z. Very simple. Okay, so by using this MATLAB command linsolve, any type of equation you can solve it. Now there are something, that is what will happen. I already told you, if the number of variables are less and number of equation is more, then what will happen? So now I am eliminating the number of variables. It is seems x and y, there are two variables. Now one variable I am just eliminating. Okay, just one variable I am eliminating here. Now I am running this program. You can see system is inconsistent, solution does not exist. So I already told you, if the number of equation is more and number of variable is less, the system becomes inconsistent and we cannot get any solution. Okay, now if I look, now if I just delete the equation number 3, only we work on equation 1 and equation 2 with two variables x and y. Okay, and I am eliminating equation 3 here. Now I am running this program. Look at this. You can get the solution now. Okay, which is x equal to minus 1/3 and y is equal to 8 by 3. So this is a very effective approach, that is a effective thing, that is lean solve, effective command to solve any kind of linear equations. So similarly, you can solve the equation with more variables, like 4 variables, 4 equations, 5 variables, 5 equations. Okay, and so on. Now let's go to the slide again. So look at this. This is another alternative coding in MATLAB to solve the coding. That is, this is three equations we have. So this is another command, solve. Okay, by using solve command. Okay, the previous command it was lean solve, but there is another command which is solve. Solve command, it can be used for system of linear equations, system of nonlinear equations also. Okay, so I am just putting this code there in MATLAB. So here, the equations, three equations are there. Okay, and the solution equal to solve equation 1, equation 2, equation 3, x, y, z. Okay, and we use this command here, xol. Xol is any kind of it is a variable, that is, it is just a name. You can use only x, you can use only y, you can use only z also. This is the left hand side, xol, it is just a name, you can change it according to you. So sol dot x, sol dot y, sol dot z. Okay, now you can use this. I think there is something, some problems is there. Okay, by the way, this is there is some problems is facing here. Okay, let's forget about it. So you can also use this command also, solve. Okay, solve command other than the lean-sub command. So now let's go to the slide again. Okay, this is our next topic, the numerical solution of transcendental equation. So what is transcendental equation? Actually, what is actually equation? So in mathematics or engineering mathematics, we all know the equation, any equation is of the type y equal to f of x. If the equation just one, I am talking about the equation of one independent variable x and one dependent variable y. And you can have different examples. Suppose if I write y equal to x square plus x plus 1, this is an equation. Okay, but this equation you can see only algebraic terms are there, x square x. Okay, if I use this equation y equal to sine x plus cos x, you can see this equation is having only trigonometric terms, sine and cos. We can write y equal to log x plus 1. This equation is called logarithmic equation since only logarithmic terms are there. But what is transcendental equation in engineering field? So transcendental equation is actually the mixture of any kind of equations. If I see this equation, the first term is 3x. It is a algebraic. The second term sin x, it is trigonometric. So when we add this algebraic equation and trigonometric equations, algebraic and trigonometric equations, so we are getting the combination of algebraic and trigonometric, and this kind of equation is called transcendental. So two or more different kinds of equations are combined together. Similarly here you can see this is algebraic term, this is exponential term, this is trigonometric term. So three types of equation, algebraic, exponential and trigonometric, are combined together. So this is another transcendental equation. So how to solve these transcendental equations? These transcendental equations are very difficult or cannot be solvable by using any classical mathematical technique, that is general mathematics. That is without having any value, that is solution. So how to solve it? You can see if I just x square minus 1 is equal to 0, we can solve it by x equal to plus minus 1 by just I am putting this 1 in the right hand side, and then just it is square root. So plus minus square root of 1 or plus minus 1 will be the solution. But if the solution equation is of type algebraic, trigonometric all together, then it cannot be solvable. So here the numerical methods or numerical solutions has a very important role here. So numerical solution, first of all, it cannot give you the exact solution. It will give you an approximate solution. So there are three techniques: method of fixed point iteration, sorry, method of fixed point iteration, bisection method, Newton-Raphson methods. There are other techniques also, so I am not talking about that. I am only talking about these three methods. But here I will talk about the most important method of fixed point iteration and Newton-Raphson method now. So fixed point iteration technique, I am giving an example. Suppose this is the, sorry, this is the equation x to the power 4 minus x minus 10 is equal to 0. Now actually in this particular method, what we do, we need to, so this is an equation of the type f of x is equal to 0. Okay, so here from this equation we need to convert this equation like this: x equal to g of x. What is g? G is any function of x, just like this. So look at this now: x to the power 4 minus x minus 10 is equal to 0. We can convert it like this: x, okay, is equal to x to the power 4 uh, plus, sorry, this is x is equal to x to the power 4 minus 10. This can also be written, so this is also another x equal to g of x form, where gx is this x to the power 4 minus 10. Or you can also use this one: x equal to x plus 10 whole to the power 1 by 4. So many forms we can find, okay, now which supports x equal to gx. So now which form is to consider? Actually, not all the form is convergent. Convergent means if I apply this, okay, technique, not all form is convergent means it can give you the value. Okay, some forms or only one of the forms can give you the solutions. Other forms cannot give you the solution. The solution may be divergent. Okay, so the condition, there is a condition. The condition is mod of g dash x must be less than 1. If this condition satisfied, then you can surely that is give you the, it will give you the, that particular form give you the convergent solution. Otherwise they cannot give you this convergent solution. So how to do this? So first we will discuss only the computational technique. So after getting the solution x equal to gx form, okay, we need to consider an initial value of x. Okay, so here you can see the initial value is considered as 1.0. So if I put 1.0 here, so I am getting what? 1.0 x equal to, just put 1.0 plus 10 whole to the power 1 by 4. After calculating this, you can get this value. This is the first iteration. And then this value is again we need to use here. That is, we need to put this here. So again, what we, if I put this x equal to 1.282116, again here, this we are getting this value x equal to this. This is the second iteration value. Again, we put this value here in the same formula. We are getting the third value of x. Again, we put this value here. We are getting the fourth value of x. Okay. Again, we put this value here. We are getting the fifth value of x. Now you can see that these solutions are matched one by one. This is the first 1.855, this is 1.8558, this is again 1.85558, and so on. So the solution, it is getting matched one by one, that is after decimal places the numbers or digits are getting same. Now if I start the initial x as 2.0, the first what we get, this is the value of x, and again we put the value of x here, we are getting this one. Again we put the value of x here, we are getting this one, and so on. So this is fixed point iteration technique. But remember, only this actually depends on your choice of what kind of equation you choose. Not all equation is convergent. Now a second method is neutron raption, which is another very effective formula, and the convergence rate is very high. That is, the speed of convergence here is very high. Speed of convergence means that is the number of iteration is low. That is, in fixed point iteration, you can see the value here, you can get 1, 2, 3, 4, 5. That is fifth iteration we are getting the value. Or here if we choose, there is 4.0 the initial value, we are getting sixth iteration to solve this. But in neutron raption, okay, it is just only 2 or 3 iterations we can solve this entire problem. So this is the technique, that is the formula of, this is the formula of the iteration formula. So here what we do, we need the derivative. That is, whatever the function, this function is given, you need to just take the derivative of this function 1 minus 2x, and we apply this formula and nothing else. And here our starting point is 1.5. Okay, so similarly here also another, you cannot choose any point, that is here we choose 1.5, you cannot choose any point. Okay, here also to, that is, if you choose any other point, the equation or the iteration method may be divergent. You cannot get the value or cannot get the solution. So the starting point, choice of the starting point is very important. Here also, and the fixed point iteration also, the choice of starting point is very important. So now we use the same process. That is, first we start with the value of x. We put the value of x here, here, and here. We get a value, we get a value of x, another x, because x n plus 1 equal to this. Again we, that value is used again here, here, and here. We get another value of x. Again that value is have to use here, here, and here, another value of x, and this iteration will go on. And here now you can see this particular x minus 2 sine x have three different roots. Here is a root, that is minus 1.895. It is another 0. So it is 0 point because the function, it is going through 0 point. So 0 is 0, 0 is obviously another solution, and which is a trivial case. And another point is this one, 1.895. Now you can see, since this function has three solutions, now which solution you need to find? The positive one, the negative one, or this one? It depends on your choice, your initial choice. Okay, which initial point you choose here. Since I choose 1.5, which is the positive direction, positive, okay, that is why we are getting 1.895 as a solution. Okay, look at this, 1.895. This is the iteration method. After this iteration x6, 1.895. So this is the solution you can see, and which matches to this curve also. You can see the positive solution is 1.895 here also. Okay, so 1.89549. So this is the big solution. So again here MATLAB, okay, is provided, provides you, okay, and different functions or command to solve these kinds of equation. You just put the equation into the MATLAB. You can use a simple command in MATLAB, you can find this value also. Okay, so we will use MATLAB now. It is what kind of solution is there. So look, so this is the function y is equal to, so first I start with, suppose very simple, x square minus 1. The solution of this function is obviously it is plus 1, that is the solution, plus minus 1. So you can see y is equal to, so this is a very x square minus 1. So the function here is f0. F0 is the command to solve the equation in MATLAB. There are many other solve equation, solve command is also can solve the equation, but here generally F0 is a very effective command in MATLAB to solve any equation. But before starting it, you need to find out, since it is only one variable function, how to write down the function. Here the function is x square minus 1. So we write in MATLAB like this, at the rate x. When I write at the rate x, it means that x is a variable here. It defines x as a variable, independent variable. And then you write the function x square minus 1. And then you use this command f0. Sol is a simple variable in which we are putting the value of f0 function. So f0 y, y is the function name. This is the function what we put in y. So y comma minus 1. Okay, so y comma minus 1. So if I run this program, and display the value of the solution, you can get -1 is the solution here. Okay, but since there are two solutions, +1 and -1, now if I put 1 here, you can see the solution becomes 1. Okay, so F0 is a very effective tool, just depending, since there are two solutions here, one negative solution and one positive solution. So this point, you can change your requirement, the positive and negative requirement, by using this particular point. If you put any positive point, you can get the nearest positive solution. If you put any negative point, you can get the nearest negative solution. Now I change this function with the function what I used here, that is this function x minus 2 sin x. So let me use this x minus 2 sin x, minus 2 into sine of x. Now look, x minus 2 sin x, there are, look at the graph, one positive solution, zero solution, it is a trivial solution, I'm not talking about that. So one positive solution, one negative solution. Okay, so what MATLAB do, so if suppose I want the positive solution of this function, so what I put, just if I put any positive number, suppose I am putting it 1. 1 is the initial point, just like fixed point iteration or neutron rapture method, an initial point is required. So here this 1 is just the initial point. If I put it, and now I solve this, look, 1.8955. Okay, and look at here, 1.895. You can see it's totally entirely matches the positive solution. Now suppose I need the negative solution. So what I did, just the initial point, I change it as any initial point, suppose -1. Okay, and I run this program now. Look, minus 1.8955. So minus 1.8955, you can also see here minus 1.895. So this is also another negative solution, entirely matches to this program. But you can also change this. Suppose anyone can say, why to use only -1 as initial point? I can use another point also. Yes, you can use -2 also. So if I put -2, also the solution will be same. Okay, so generally if I need the negative solution, then I put any negative number. Okay, if I put any positive solution, I should put a positive number here. So this is a F0, a very effective solution process, F0, to find out any that is no find out the solution of any kind of transcendental equation. Next, another problem, mathematical problems, which is ordinary differential equation, which is very much important for any engineering problems. Differential equations, so engineering problems and differential equations, they have a very close relationship. Okay, many engineering problems, most of the engineering problems, differential equation is formed, and there are two kinds of differential equation. One is ODE and another one is PDE. Okay, ODE, it means that ordinary differential equation, ordinary differential equation, and the second one, another one is PDE, and which is partial differential equation. Okay, so ODE and PDE, there are two cases. So PDE is a, ODE and PDE both have different types of equations. Okay, and different types of solution process also. So it is a very huge chapter, that is PDE. It will take near about 3 hours to complete in where MATLAB uses the finite difference method to solve ODE. So it's a tool, a package is there to solve PDE. So in today's lecture, I cannot discuss about PDE entirely. So PDE is not possible how to solve in MATLAB or a solution process in mathematics. So I skip PDE. I will only concentrate on ODE today and how to solve ODE in MATLAB and different types of ODE. So there are how many types of ODEs are there? ODE may be linear, okay, linear, maybe non-linear, okay. Now linear ODE, it may be different order ODE is there, first order, second order, third order. Non-linear is also there, maybe second order, first order, third order, okay. So a differential equation has two things. One is degree and another one is order. Okay, degree of the differential equation, it actually depends on whether any square term or nonlinear power. Okay, more power more than one or less than one, any kind of power is there or not. Okay, which is not equal to one. Okay, that is power must be either greater than one, okay, or maybe less than one, but not equal to one. Then the degree linear equations, it is only that kind of differential equation where the degree is 1, okay, and other case of all equations are non-linear. So linearity and non-linearity, it depends on the degree of the differential equation, whether degree is 1 or degree is not 1. And order, it depends on the order, depends on how much order differential is there. The differential equation may be first order, maybe second order, maybe third order. So highest number of order of the differential equation present in that equation is called the order. So depending on that, different types of differential equations ODE and PDE are there. So since we are talking about only ODE, so in numerical methods, analytically there are many types of solution process. Okay, the solution process may be separating the variables, linear equation solutions. Okay, finding the integrating factor. Okay, so there are different kinds of methods present, but whatever the method, analytical methods are there, there is no comparison to numerical method. However, the numerical method cannot give you the exact solution, but also any kind of differential equation can be solved by using numerical solution technique. So generally there are three solution techniques: Euler's method, modified Euler's, Runge-Kutta method is there. Okay, Runge-Kutta method are of fourth and second and fourth order. Okay, so analytical solutions, it will be very large. So I'm not talking about that one. Directly I'm going for the MATLAB coding to solve any ordinary differential equations. Okay, so look at this. This is sorry an equation. Okay, ordinary differential equation. The order you can see here, it is degree 2. Okay, and order it is 1 because only dy dx is there. There is no higher order differential is there, and the degree of the differential equation, it is equal to 2. And there is a condition also, which is called the initial condition. Okay, so differential equation, if only differential is equation is given, the solution, always remember, the solution of differential equation is not a value but a function. Okay, is a function. So when you get the MATLAB solution, you will get a function. If there is any kind of condition is given, you can get only one equation. If no function is given, only differential equation is given, you can get many solution or many functions. Okay, and which is called the family of curves. So generally differential equation solution, it gives you family of curves without any condition. General differential equation without any condition. If any condition is given, then this solution family of curves, it becomes a particular solution and gives you one curve only. So here you can see this both the differential equations having initial conditions. Here the two conditions are there. Here one condition is there, and the there is a very simple way to solve any ODE in MATLAB, and this becomes SY sims. Sims means it is symbolic. So YT, that is we are defining this symbol only YT. That is Y is a function of a single variable T. Okay, ODE, it is just a variable, is equal to di double f yt. It means that dy dt. Okay, diff or di double f, it is actually defines dd x or ddt whatever. Okay, if I write diff yt, it means dy dt, the independent variable here it is t. So ddt of y plus y, that is here you can see dy dt plus y. So diff yt plus y whole square. So whole square equal to 1. This is equal to, in MATLAB we use equal double equal here to represent the equality. And the condition is here, condition y0 is equal 0. Now this is the main command, dsolve. Okay, dsolve ODE condition. So when you use dsolve ODE and condition, that is ODE means this is the ODE. Okay, so ODE, this is the ODE, and condition, this is the condition. Just you write dsolve within bracket ODE condition. The MATLAB will give you the exact solution of that. Look at this second now, second equation. This is second order ODE differential equation. Condition 1, condition 2, there are two initial conditions are there. So dy, it is just a variable, is equal to dif y. Okay, so differential equation of y. So ODE, it is yx2. Why it is yx2? So yx2, it is, y means dependent variable, x means independent variables, 2 is the order. Okay, so dif yx2, it means d2y dx2, it is given. Okay, so we only use di double f only x comma y like this, or y comma t whatever, it means dy dt single order, but xy2 dual order or second order. Okay, is equal to cos 2x minus y. So equal to represents the equality sign, cos 2x minus y. Condition 1, the condition, since there are two conditions, so condition 1 and condition 2, we have to write here two conditions. Y0, so y0 equal to 1, y dash 0, so dy. Okay, or only you can, instead of writing dy, you can also write diffy equal to 0. This one you can also write here. So these two conditions, now you use solve. Okay, or y solve t is equal to d solve. Okay, d solve ODE condition 1 and condition 2. If you use this command, there you can, the MATLAB will give you the solution here. So let us go to the MATLAB now. So here you can see here that what is this differential equation? This is OD equal to difference di double f y plus 4y is equal to exp minus t. That is, it means that here the equation is like this, di double f, just wait, it is difference y plus 4y is equal to minus t. So t is the independent variable. Sorry, t is the independent variable here. So it is dy dt plus 4y. The equation here, it is actually dy dt plus 4y is equal to, the right hand side is exp minus t. It means e to the power minus t. So this is the equation what is written there. Okay, since t is the only variable, so now go to the MATLAB here. Yes, this one. Now condition is given y0 equal to 1. You can see y solve t is equal to d solve ODE condition. Okay, and DISP is nothing but the display. Now if I run it, look, this is the solution of it. Okay, since I already told you, since it is the equation, this equation is actually the equation of, there is a condition is given. So in this condition it will give a particular solution, so no arbitrary constant is there. Now I told you that this differential equation is actually gives you, that is what it gives you, the function. It gives you the function. Since it gives you the function, so you can plot it also. So I'm going to plot this. I'm going to plot it now. Okay, first I'm plotting it by using this. Look at this plot. This plot is not at all looking good. Okay, so let me introduce some, is 0.01 length and everything. Look, now if I plot it, then the plot is, it becomes very smooth plot. Okay, now if I smaller the size of the mesh here, that is uh, distance 0.001, 0.001, and plotting this graph, run. Look, now it becomes more and more smoother. Okay, if I decrease the distance, that is the point, that is mesh points near equal to, then it becomes more and more smoother. So this is the particular curve. Okay, now you can change this equation also. You can change different types of conditions what we use here. So just like you can use, so let us use this one, this function. Okay, there are two conditions. Let us use it here. So here it is y solve t, since t is the only single independent variable here. Okay, and I told you that is variable, the d solve is the only function what you need to use here, d solve. Okay, within bracket. Now what is the ODE? D solve ODE, comma, condition 1, condition 2, condition 1, condition 2, and now we display, y solve. Okay, there is condition there. Okay, cannot solve it, something is Missing. Okay, whatever. So let's try another one. Maybe this equation is not solvable. Yes, look at this. The y solve. This is the condition. There is the solution. What is the solution? The condition is here. Okay, this is the ODE here, and this is the solution here. So y solve equal to this one, and it gives you the solution like this. That is, if I display display this one, display y solve t. Look, the equation is displayed here. Okay, so this is the way you can solve any kind of ODE. There is main thing what you need to use, desolve. Desolve is the command. Now more desolve command, there are how many iteration, that is arguments are there, how many variables you can use here inside this function. There are many other variations of desolve also which you can get in the MATLAB website. Okay, many kinds of things are there. Okay, so this is all for today, and we have what we have done today, that is what we have learned. There are three conditions, three cases we have learned. System of the numerical techniques of system of linear equations. Okay, and the second one, the transcendental equation solutions, the numerical techniques. Okay, there are three techniques of fixed point iteration, neutron raption, and another is bisection. Bisection is not that much important, so that is why I did not discuss that one. And the third one is, it is the ordinary differential equation, and all kind of MATLAB coding. What kind of coding is there? Okay, you can use any kind of MATLAB coding to solve any kind of numerical solutions of any mathematical equations. Okay, so in engineering cases, since equations are too much different, any analytical solution is not applicable there. So numerical solutions, by using this MATLAB, if you use MATLAB, it will be very very easier. Okay, you can also solve the equation also along with the different types of graphical representations. Okay, so thank you very much, all of you.